Okay, welcome seniors to this video, and this video is intended especially for grade 12 ASP studying at ATHS schools. In this video, I will be explaining everything related to titration. I've received many comments from students that they need further explanation regarding titration. Okay, now to start with, I will explain for you what is the setup in your school labs. Okay, in titration, I have two. The first solution will be placed in this flask. Okay, will be placed in now, the solution that is placed in the flask is acid. This means for sure fill urine a base. And the opposite is true. If you put in your flask a base, you will have to fill your burette with an acid. Okay, now the procedure is as follows. I have a flask. I put in it a certain volume of acid. I know how much of acid I put. So this is the volume of acid. For example, this might be 10 milliliters. After I put my acid here, I will put few drops of indicator. Is very important. The color changes. This means I reached the equivalence point. Okay, so I put the indicator here together with the acid. Now the solution in the flask is ready. Now in the burette, I will fill it with the base. Okay, and in titration, I will be adding the base. I stop adding base when the color of the indicator changes. Okay, so general titration. Now in titration, there are that I want you to know. Is analyte, and the second is called. Now the analyte is the substance that is usually placed in the flask. Remember, this looks like the letter A. Okay, so the analyte is the substance here. In my case, the analyte is the acid. Okay, and the second substance is the titrant. Remember, this looks like the letter T. So the titrant is usually here. It is in the burette. And in my case, the titrant is a base. You might be asked in the exam, what is the analyte and what is the titrant? Now the analyte is the one that is down. The titrant is the one that is up. Okay? Usually, the word analyte is taken from the word analysis. Analysis means I'm analyzing this substance to know its molarity. So usually the substance that I place here or the acid, this one have unknown molarity. Okay, so I do all this titration in order to determine the molarity of the analyte. Okay, so analyte means analysis, means the one that is placed down. Titrant is the substance that is placed in the burette. And if the analyte is acid, the titrant is base. If the analyte is base, then the titrant is acid. Okay? Hello. Whenever we do the titration, we will have something called titration curve. Okay? Titration curve is something like that, looks like this. This is a titration curve. Now we have 4 different types of titrations. This one, and this one. Okay, now I want you to tell me in each case, what is the analyte? Okay, and what is the titrant? Okay, how will we know which one is the analyte and which one is the titrant? First of all, I want you to look at the beginning of the graph. Here the graph starts at 0. 0 means I am titrating a strong acid. So the substance that is here, this is an acid. Okay, now it ends at 13. So the titrant is base. Okay, so the analyte is acid, the titrant is base. Now, if you look here in this graph starts at 11. This means that the substance that is here is a base. Okay, we start with the base. In the beginning, I have only base. Now I will start adding to it what? Acid. Okay, similarly, if we look here, we start at a pH of 3. This means this substance here is acid. We are starting with acid and then we are adding to it base. Okay, and here we are starting with pH of 13. This means that the substance here is a base and I'm adding it here acid. Okay, طيب هلا when I draw this graph on the x-axis I have volume. Volume of what? Now I have two volumes. I have volume of acid, volume of base. But the volume of acid is fixed, which is the volume that I already put here. This is fixed. This is not variable. What is variable for me? The volume of base. I'm adding base drop by drop till I reach the equivalence where the color changes. So here, the volume here represents the volume of base added because I am adding base. Okay, طيب, let's look here. Here I have the base is fixed and I'm adding acid. So this volume is the volume of acid added. Okay, similarly here I'm adding a base, so this is the volume of base. And here I'm adding acid, so this is the volume of acid added. Okay. Now, second thing that I want you to know, that how will I know if this base and this acid, who is strong, who is weak? Maybe both of them are strong. Maybe this is strong, this is weak. We will not do a graph of weak base with weak acid because the graph will be a mess. Okay. طيب كيف هنعرف who is strong, who is weak? The most important point to look at, actually 2 points to look at, is initial. Initial means starting. Here it starts at 0. Okay, so this is a strong acid. The second most important point is called the equivalence point. Equivalence is taken from the word equal. So the equivalence point, at this point, I have the moles of acid is equal to the moles of base. Now, where is my equivalence point on the graph? My equivalence point on the graph is you look at this straight line and you take its midpoint, okay? Where is the midpoint of this? It's here. And then we will stretch it to the pH. What is the pH here? The pH is 7. Now, if the equivalence point is at pH of 7, this means I'm titrating strong base with strong acid. Okay, let's look here. This one does not start flat like this. It goes with a jump. And this one starts at 0. This one starts at 3. So this is another difference. Now let's see the equivalence point. Look at this line. Take the midpoint. The midpoint is almost here. This is 1, 1 here. Okay. Notice that the equivalence point here, this is the equivalence point. At this equivalence point, the pH is 9. If the pH is above 7, which is 9, this means that the base is strong and the acid is weak. Okay, now let's see the equivalence point here. Look at this straight line, take its midpoint, stretch it here. Now the pH at equivalence is 5. Is 5 يعني the strong هو الacid. يعني the acid is strong and the base is weak. Okay, now let's look at the equivalence point of this graph. This is the equivalence point. Okay, so I have here, this is 7. So I will say the acid is strong and the base is strong. إذا من الجراف you have to identify 3 things so far. You have to tell me who is the analyte, who is the titrant, and if the analyte is strong or weak and the titrant is strong or weak. Okay, إذا we have 3 types of equivalence point. Equivalence point at 7, equivalence point at 7 like this one, and this one means both of them are strong. If the equivalence point is 9, this means the base is strong and the acid is weak. If the equivalence point is less than 7, this means that the acid is strong and the base is weak. Okay, the third thing you need to know from the graph is the if a substance is weak, we need to know its Ka. طبعا هدول الاثنين strong إذا ما عندنا Ka. بما إنه أنا هون عندي strong base weak acid, the weak acid must have a Ka value. Now how can I tell my Ka value from the graph? Ka value usually is found at the half equivalence point. Okay, let me show you another graph. This graph, okay, I will be writing all the information that you need to know here. Now, what is point number 1? Point number 1 is the initial pH. We are starting at 3. Okay, so here I can represent my titration like this. Okay, this is the titrant, this is the analyte. What is the analyte? The analyte starts at 3. This means the analyte is acid. Okay, what am I adding? What is my titrant? My titrant is the base. So here volume of base added. Okay, now if I want to know who is the strong, who is the weak, what will I do? I will look at the pH at equivalence. This is the equivalence point, okay? The equivalence point is at 9. This means that the base is strong and the acid is weak, okay? طب هلا second thing. So this is called the equivalence point. Now, if I'm titrating an acid, for example, HF, let's say HA, generally speaking, HA. HA is any weak acid, okay? I will not identify A. طيب, what happens when I am adding a base? طبعا base يعني OH minus, okay? And this is double arrow because it is weak. What are the products? The products will be HOH plus A minus. هلا, whenever I see HA and A minus, what does this remind you? HA, this is the weak acid, and its conjugate A minus. This means that this is a buffer. How do I calculate the pH of buffer according to Henderson? pH equal pKa plus log B over A. Okay, but when is the best buffer capacity? The best buffer capacity is when B is equal to A. B is equal to A, what does it mean? This means that B over A is equal to 1. Log 1 is equal to 0. This means that in this point pH equal pKa. هلا وين هاي البوينت على هذا الجراف؟ Okay, the buffer region where I have a weak acid and I'm adding to it strong base is this region. So this region all is called buffer. What type of buffer do I have? I have acid and conjugate base, so this is acidic buffer. Okay, this region will be divided into 3 parts. If this is the equivalence point, this is 20. Okay, what is half of 20? Half of 20 is 10. Okay, so this point is called half equivalence point. Half equivalence point. شو بستفيد أنا من هاي البوينت؟ على ال half equivalence point, here in this location, B is equal to A. That's what I said here. B is equal to A. So pH is equal to pKa. How much is the pH here? The pH is around, let's say 5. Okay, so the pH is 5 equals pKa. You know P is minus log, so 5 is equal to minus log Ka. So Ka is equal to 10 to the minus 5. إذا أنا قدرت أعرف ال Ka لهذا الويك أسيد على أي point؟ على half equivalence point. Very important دائما عند ال half equivalence. How will I know the half equivalence? If the equivalence point is at 20, half of 20 is 10. So we go at 10 and we see the pH. The pH is equal to pKa. Now what happens in this region before the half equivalence? Before this region, I have both HA and A minus. But who is more in this region? I will label this region as A, and this region, I will label it as B. Okay, before half equivalence in region A, who is more? طبعا هون نحن بالأسيدك region. يعني ال HA is more than A minus. Okay, طب هلا in region B, after the half equivalence point. In this point, the base is more than the acid. So in region B, the A minus is more than HA. Usually you get a question in the exam, they give you, for example, pH of 4. Okay, pH of 4 يعني هون. And they ask you, who is more, the weak acid or the conjugate base? Okay, so if this is before the half equivalence, كل هاي الاريا, then HA is more than A minus. Now after half equivalence, all this area, A minus is more than HA. Okay, at the half equivalence point, HA and A minus are equal. Okay, so we use this point to find the Ka of the acid. Okay, now point number 4, this is the basic region where I have only the strong base and the pH is 12, so means I have strong base. Okay, so I want you to concentrate on the equivalence point and the half equivalence point. Okay, so let's go back to this question. If I have here a strong acid, strong base means they do not have Ka and they do not have Kb. Let's look here. Here I have strong base is being titrated with weak acid. Now the weak acid have Ka. I need to know how much is the Ka. Where do I look at? I need to find my half equivalence point. Okay, so the equivalence point is here. It is at 20. What is half of 20? It's 10. So this is the called half equivalence point. Now what happens at half equivalence? Base is equal to acid. So pH is equal to pKa. How much is the pH? The pH is 4.5 or 5. This is equal to pKa. Then I can say Ka is equal to 10 to the minus 5. Okay, now let's look at this graph. Now in this graph I have strong acid versus weak base. Weak base لازم يكون عنده Kb. Now how do I find Kb? Okay, similarly the equivalence point is at 20. Half equivalence is at 10. So this is the half equivalence point. Now what happens at half equivalence? pH equal pKa. pH equal pKa. How much is the pH here? It's approximately 9. So I will say 9 equals pKa. I don't want pKa. I want pKb and then Kb. How do you change pKa to pKb? You know, very important rule, pKa plus pKb is equal to 14. Now pKa is 9 plus pKb is equal to 14. So Kb is equal to 14 minus 9. This is 5. pKb, sorry. So Kb is equal to 10 power minus 5. Okay, دائما من الجراف we find Ka. If we want Kb, you can change it to Kb. If you want Ka, just leave it as it is. Okay, هلا هون I have strong acid, strong base, none of them have a K value. So these are the most important points that you need to know in the titration curve. Okay, now I will be solving some AP questions related to the titration curves. Now let's start with the first question. Okay, if you want, pause the video now, read and solve, then check with me your answers. Okay, we have this acid plus H2O. This is in equilibrium with CH3, CH2, COO minus. Now what did this acid do? It had an H, it lost an H. So this one is the acid. طبعا دائما صاحب الأسد اسمه conjugate base. طب now H2O, what did it do? H2O, H3O. So this one gained H. Any substance that gains H is a base. وصاحب البيس بيكون conjugate acid. ممنوع 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 ألاقي هاي acid وهاي acid. أو هاي base وهاي base. If this is an acid, this is a base. If this one is conjugate base, this means this is conjugate acid. Okay? طيب. At 25, the pH of 50 milliliter of 0.2 molar is 2.79. So the pH is equal to 2.79 and the volume of acid. I advise you whenever you write volume or molarity لا تكتبوا M بس, اكتبوا A or B. If it is acid, write A. If it is for base, write B. Okay? Now the volume is 50 milliliters and the molarity is 0.2 molar. Okay, question 1. Identify Bronsted-Lowry conjugate acid-base pairs. We already identified and clearly label which is acid, which is base, so this is done. Now determine the value of Ka for propanoic acid. بما أنه propanoic acid is a weak acid, and here we see double arrow, this means it's a weak acid, it should have Ka. Now the rule for calculating Ka is equal to x squared over C minus x. C is the concentration, it is 0.2, and X is the concentration of H plus. Okay? طيب C is given. This one is 0.2. ما عندنا مشكلة. عندنا مشكلة بالX. How can I find X? From the pH. pH is equal to minus log H plus, which is minus log X. If the pH is 2.79, this is equal to minus log X. And then X is equal to okay, you find X and then you replace it here in the Ka value, and I think the answer will be Ka is equal to 1.3 times 10 to the minus 5. Okay, you can also do it by using ice table. Let me show you. If you have an ice table, the acid is CH3, CH2, COOH, plus H2O, double arrow, CH3, COO minus مع H3O plus. Be careful لما نعمل ice table ما تقلقوا بال H2O لأنها liquid anyway, it will not appear in the equilibrium expression. Okay, so initially I have the concentration is 0.2. Initial change equilibrium, this is 0, 0, minus X, X, X. This is 0.2 minus X, X, X. Now the Ka is equal to products over reactants. The products are these, X times X. Reactants 0.2 minus X, which is equal to X squared over 0.2 minus X. That's what I said for you here. You can say Ka equal X squared over C minus X, okay? طيب, هلا, in order to find Ka, I need to find X. I will find X from the pH equal minus log X. X is H plus, okay? So the pH is 2.73. This is equal to minus log X. I can search for X, and then I can place it here. I will get Ka 1.3 times 10 to the minus 5. Okay, طيب. Now let me erase and do question C. Now for each of the following statements, determine whether the statement is true or false, and in each case explain. The pH of a solution prepared by mixing 40 milliliters of 0.2 molar this acid with 50 milliliter sample of 0.2 molar NaOH is 7. Now remember, if I mix acid and base, the pH will be 7 at equivalence only if both of them are strong. So if I'm titrating strong acid مع strong base, this is true. But if I have a weak acid with a strong base, this is false. The pH will be more than 7. ليش؟ لأنه البيس هو strong والacid هو weak. By the way, I want to remind you with the list of strong acids. You have 6 strong acids. You should memorize, because if you do not memorize, you will not be able to know if the acid is strong or weak. Okay, the strong acids HCl, HBr, HI هدول من الهالوجنز. بعدين عندنا الأوكسي acids HNO3, HClO4, H2SO4. Okay, this is the list of strong acids. اوكي عشان تتذكروهم هم H مع Cl و Br و I، هدول الثلاثة HCl و HBr و HI. اوكي هلا ال H مع ال N حتكون HNO3، ال H مع S حتكون H2SO4 ومع ال Cl حتكون HClO4. هدول الستة strong acids you should memorize them for the test. هلا نشوف السترونج bases. السترونج bases طبعا حيكونوا مع الميتالز. اوكي السترونج bases are very easy to memorize. If you have a periodic table, okay, you will take them like this. The strong acids, okay, sorry, strong bases. Okay, the strong bases. عندنا Li مع OH و Na مع OH و K مع OH. إذا هدول الثلاثة strong acids LiOH NaOH و KOH. أوكي هلا بنيجي هيك عندنا Ca هون رح نحط OH2 لأنه هدول الجروب التشارج إلهم +2. اوكي وSR OH2 وBaOH2. إذا هدول الليست of 6 strong bases. LiOH NaOH KOH. بعدين بنمشي يمين CaOH2 SrOH2 BaOH2. هدول الستة هن السترونج بيسز. اوكي لازم تحفظوا السترونج acids والسترونج bases عشان تعرفوا if you are given an acid or a base is it strong or weak. اوكي إذا هون عندنا ال NaOH is a strong base and this is weak acid. إذا the pH at equivalence will be more than 7. Now if the pH of hydrochloric acid solution is the same as the pH of propanoic acid عندنا HCl مثلا ال pH equal 1 وعندنا propanoic acid طبعا هذا weak acid وال pH also is equal to 1. طبعا ال strong acid لازم يكون عنده less pH عن ال weak acid. If it happens to be the same pH, this means that this weak acid is very concentrated. Okay, very concentrated عشان هيك يكون عندهم نفس ال pH or else they will not have the same pH. Then the molar concentration must be less than the molar concentration, so this is true. Now, a student is given the task of determining the concentration of propanoic acid. شو يعني concentration of propanoic acid؟ يعني molarity of acid. The student uses 250 milliliters to deliver the acid. إذا I will say V acid ما تنسوا تحطوا A عشان تعرفوا is this acid or base. Okay, and then titrate the solution of 0.1 molar NaOH. So this is the molarity of the base. Reaching the end point at 20.25 milliliters. So this is the volume of base, 20.52 milliliters. Okay. طيب دائما يا grade 12 seniors, in order to calculate the molarity is calculated at equivalence point. If you remember in this graph, we identified 2 points, equivalence point و half equivalence point. ال half equivalence point بنستعملها لنحسب ال Ka. طب شو فايدة ال equivalence point? At equivalence, moles of acid is equal to moles of base. So, MaVa is equal to MbVb. لأنه أنتم بتعرفوا من grade 11 إنه المولاريتي هي moles على volume. So, moles is equal to molarity ضرب volume. So, I will replace moles of acid by molarity times volume of acid. Moles of base MbVb. إذا هذه it happens when على equivalence point. على equivalence point بيكون معي 3 من هدول and then I find the last one. Okay. طيب now let's do the same idea here. I will say in order to calculate the molarity of the acid, MaVa is equal to MbVb. Okay, you will place instead of Va 25, Vb 20.52, Mb 0.173, and you will find Ma will be equal to 0.142 molar. Okay, now the student is asked to redesign the experiment to determine the concentration of butanoic acid instead of propanoic acid. For butanoic acid, the pKa is 4.83. Okay, how do we find pKa? دائما لما نشوف P هي minus log. Okay, so pKa is minus log Ka. طب للبيوتانويك acid it is 4.83. Can I find it for propanoic acid? هاي الأسيد طبعا لأنه I just found the Ka value. The Ka here was 1.3 times 10 to the minus 5. So if I need to find the pKa, I will do minus log 1.3 times 10 to the minus 5. So the pKa will be equal to 4.77. Okay. 4.83, 4.89. Okay. طيب 4.89 and 4.83 are very close to each other. Okay. إذا ال half equivalence point butanoic acid will have equivalence point للpropanoic acid are almost the same. The students claims that a different indicator will be required. طبعا we will not require a different indicator لأنه they are very similar. So same indicator can be used. Okay, yeah, another question. Okay, please pause the video and solve by yourselves and then check your answers with me. Okay, you have this substance, a stock solution. A student titrates 45 milliliters of the stock solution with HCl. يعني here I put 45 milliliters of the stock solution اللي هو KC6H7O2 and I'm titrating it with HCl and the molarity of the acid is 1.25 m. Okay, using both an indicator and pH meter, the Ka is هالقد. Write the net ionic equation for the reaction between this one and this one. Okay, هلا بالnet ionic equation I will only consider the important ones. طبعا من ال HCl هذا acid شو المهم عندي؟ ال H plus only. So I will take from this H plus. من هاي what is important for me? If this is plus, so I will take the negative part from this. So I will not take this, I will take this one. So the net ionic equation will be H plus C6H7O2 minus. طبعا double arrow لأنه هذا weak. H C6H7O2. A total of 29.95 milliliters of HCl. So the volume of acid is equal to 29.95 milliliters. Calculate the concentration. طبعا like we did before, I will do MAVA is equal to MBVB. Okay, molarity of acid 1.25. Volume of acid is 29.95. Molarity of base I needed. Volume of base is 45. هون ما في داعي نحول الفوليومز لليترز. Both of them are milliliter is okay. Okay, and then I will find the molarity of the base, which is equal to 0.832 molar. Now the pH at the equivalence point is 2.54. طبعا نحن we are expecting the pH to be less than 7 because I'm titrating a strong acid with weak base. Okay, if this is strong acid, this is a base. pH 2.54. Why? Because the acid is stronger than the base. Which of the following indicators will be the best choice? طبعا نحن حنختار الانديكيتور يلي ال pH له كتير قريبة من 2.54. Okay, which one is the closest? It is this one, thymol blue. Calculate the pH at half equivalence. Remember, what happens at half equivalence? At half equivalence, B is equal to A. So pH is equal to pKa. Okay, يلا. شو يعني pKa? يعني minus log Ka. Okay, Ka is 1.7 times 10 to the minus 5. So I will say minus log 1.7 that 10 to the minus 5. And this will give me 4.77. Okay, the equivalence point will be at 254 and the half equivalence point will be at 4.77. Okay, هذا titration curve will look like this. طبعا بما انه اللي تحت base I will be starting from a point above 7. بما انه weak حتكون فيها jump مش حتكون flat. بعدين I will have like this and then like this. Okay, the equivalence point here is at 2.54. Okay, and this is the half equivalence point. 7 will be 4. Okay, anyway. Okay, now next. The initial pH and the equivalence point are plotted on the graph below. Okay, so we have this is the initial pH يعني البداية and the equivalence point is here. Accurately sketch the titration curve. Mark the position of the half equivalence point on the curve with X. طبعا ال equivalence point is at 30. وين ال half equivalence point حتكون at 15. طب 15 مع أي pH I will match it. I will match the 15 with okay, the pH at half equivalence 4.77. So the 15 will be here 4.77 يعني تقريبا هيك. Okay, so the graph will look like this and then like this. Okay, and then it will end in the acidic region. This is the equivalence point. Equivalence point هي midpoint لهذا الخط. والhalf equivalence is at 15. So this is the half equivalence point and this is the initial pH. Okay. Yeah, now another question. To produce an aqueous solution of HNO2. قبل ما نبدأ خلينا نعمل analysis للجراف. Okay. What am I titrating versus what? بما إنه مبلشين ب pH less than 7, this means the analyte is acid and the titrant is base. طيب هلا إذا بدي أعرف أنا مين السترونج acid ومين الweak ومين السترونج base أو weak base, so where do I look at? I look at the equivalence point. اوكي خلينا نشوف الايكوفالنس بوينت هي تقريبا هون او هون. اوكي so the equivalence point is at pH of 8. This is the equivalence point. وتذكروا على equivalence point MAVA is equal to MBVB. اوكي so at equivalence point is at 8 معناته البيس هو strong والاسيد هو weak. اوكي طيب هلا هون what am I adding? I'm adding base عشان هيك رح اشوف هون على الاكس axis volume of KOH added, volume of base added. اوكي طيب to determine the concentration of HNO2, a student titrates 100 milliliters sample of the solution. إذا أخذنا من الacid volume of acid is equal to 100 milliliters. I'm titrating it with KOH. The molarity of the base is equal to 0.1 molar. Okay, use the titration curve and the information above to determine the initial concentration of HNO2. دائما لما يقول لكم concentration of the acid يعني M acid. Which is the best place to find M acid? طبعا at the equivalence point. Okay, the equivalent at equivalence MAVA is equal to MBVB. طيب هلا molarity of acid is needed. Volume of acid used is 100. This is equal to molarity of base is 0.1 times volume of base ما أعطاني إياه at equivalence. How will I solve? I can find it from here. هاي ال equivalence point, هاي ال volume of base. بنروح على الجراف بنشوفه قديش 20. Okay, and I can find the molarity of the acid. So the molarity of the acid will be equal to 0.02. اوكي طيب هلا السكند بوينت بما انه هو ويك اسيد يبقى عنده KA. Where will I look to find KA? بده هو PKA. اوكي I will find the KA at the half equivalence point. The equivalence is at 20. So نص ل 20 10. So I will go to the half equivalence point. At this point, okay, this is called half equivalence point. At this point pH is equal to pKa. ليش؟ لأنه ال A is equal to B. الacid والbase. طبعا when I say acid وbase, I don't mean this acid and this base. I mean this acid, the weak acid, and the conjugate base. هدول الاثنين بيكونوا قد بعض على هاي البوينت. Okay? I don't mean acid is equal to base. This base is equal to this acid at the equivalence point. Okay? يعني ال KOH is equal to the weak acid اللي هو HNO2 على equivalence point. بس على half equivalence قلنا انه هذا بنعتبره buffer region. فالبفر عبارة عن weak acid و conjugate base. فهدول الاثنين بيكونوا equal على half equivalence point. اوكي طيب كم ال pH هون؟ I think it is 3.2. So pH is equal to pKa. This is equal to 3.2. Okay, approximately, and there is no unit. طيب during the titration after a volume of 15 milliliters of KOH has been added. خلينا نشوف وين ال 15 milliliters. 15 milliliters of KOH يعني I'm talking about this point. Okay. هون أنا. Which species HNO2 or NO2 is present at a higher concentration and justify your answer. إذا متذكرين نحن قلنا إنه هذا الريجن هو عبارة عن buffer. على half equivalence point بيكونوا الأسيد والبيس قد بعض. Before half the equivalence بيكون الأسيد أكبر من البيس. يعني بهذا الريجن بيكون HNO2 أكبر من NO2-. بعد الهاف equivalence بيصير العكس. البيس أكبر من الأسيد. يعني NO2- أكبر من HNO2. Okay, so at 15 طبعا NO2- is more than NO2, HNO2, because justify your answer, because this is after half equivalence point. Okay, إذا نتذكروا عنا at equivalence point MAVA equal MBVB, at half equivalence point pH equal pKa. قبل هاي البوينت بيكون الأسيد أكبر من الكونجوجيت بيس، وبعد هاي البوينت بيكون البيس أكبر من الأسيد، أو الكونجوجيت بيس أكبر من الأسيد. Okay. Next, I suggest now you pause the video and you resolve the questions all by yourselves, and then you check your answers with me. I know this video will be long, but I'm trying to solve as much questions as I can. Okay, I will be faster now. Let's do this question. Okay, the ionization of HF. طبعا HF يعتبر weak acid. كيف عرفنا انه weak acid؟ مجرد شفنا double arrow هون يبقى هو weak acid. Weak acid يعني بيعمل partial ionization. يعني not all of the H plus HF will ionize. Part of it will make F- and H plus, part of it will stay as HF. Okay, this is the molarity of the acid. So the molarity of HF is 0.035. The percent ionization is 13%. تذكروا formula البرسنت ionization هي H plus على HA ضرب 100. اوكي، هاي هي ال HA، والpercent ionization هي 13%. So if I place this one with this one, I can find H plus. Let's see what is the question. Two particle diagrams are represented below. Water molecules are not shown. Explain why the representation in figure 1 is more accurate than figure 2. Let's see what do we have in figure 1. In figure 1, we have this gray and this black, which means HF, high HF, high HF. Then I have here 1, 2, 3, 4, 5, 6, 7 HF. وعندي هاي يلي هي F- وحدة. وعندي H3O+. H3O+ هي نفسها H+. شيلوا منها H2O بتصير H+. اوكي، عندي وحدة H+. طب let's see here what happened. Here we have F- 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 F-. وعندي 8 H+. اوكي، ما عندي HF. طبعا هاي غلط لأنه هو بيعمل partial ionization. So partial ionization يعني I should see HF و F- و H3O+. Okay, so this is correct. Now use the percent ionization data to calculate the value of Ka for HF. Now this one needs two-step equation. Our step, I will use this one to find H+. Okay, so percent ionization is 13%, is equal to H+ over the concentration 0.035 times 100. I will find H+. Second step, I will say Ka equal x squared over C minus x, will x هي H+. Okay, so solve and find the answer. The answer will be 6.8 times 10 to the minus 4. Now, if 50 milliliters of distilled water was added, will the percent ionization increase, decrease, or remain the same? طبعا when we add water, let's see what will happen to the reaction. If we add water, this is water. Where will the reaction go? The reaction will go forward. So adding water According to Le Chatelier principle, the reaction will go forward. When it goes forward, means more ions, more F minus, more H plus. More ions, this means Ka will increase. Okay, دائما when I add water, there will be more ions and Ka will increase. Now let's do another question. Okay, we have methanoic acid. Write the expression for the Ka and calculate the pH. This is an easy question. طبعا Ka, when he says expression, means no numbers, means in letters. Ka is products over reactants. The products are H3O plus times HCOO minus over, طبعا هاي will not be counted because it is liquid, HCOOH. Okay, طيب. Also لو عملتوا ice table راح تطلع x ضرب x over c minus x or x square over c minus x. Now calculate the pH of the solution. طبعا C 0.25 وال Ka is 1.8 ضرب 10 to the minus 4. Okay, then you find x وال pH بتكون minus log x. Okay, 0.0067 and this one will be 2.17. Okay, another question. Now a student titrates 20 milliliters of weak acid. Before we start, can you tell me what is the analyte, what is the titrant? بما انه نحن بادئين من تحت, this means that I'm titrating the acid and this is a base. طبعا هذا الانالايت لانه هاي بتشبه حرف ال A وهذا التايترنت. طيب لو بدي اعرف مين سترونج ومين ويك, خلينا نشوف ال pH at equivalence. شايفين هذا الخط؟ Okay, now the midpoint is here. Okay, so it is at 7.5. بما انه 7.5 يبقى البيس هو strong والاسيد هو weak. بما انه الاسيد هو weak يبقى عنده Ka. And if I want to find the Ka, where do I look at? I look at half equivalence. Okay, the equivalence point is at 10. So the half equivalence نص 10 will be 5. So the half equivalence is here. At this point, MAVA equal MBVB. At this point, pH equal pKa. Okay, كم pH? pH 3 equal pKa. يعني Ka is 10 power minus 3. Okay, إذا I can use the graph to find the Ka of the acid. طب هلا لو أنا بدي أستعمل هذه الفورمولا وما عندي الفوليوم of base given بالسؤال, I can use this volume. كم الفوليوم؟ 10. Okay. طيب now let's do the questions. Use the information to estimate the pKa. طبعا we found that the pKa is 3. When the pH of the mixture is about 4, is there higher concentration of weak acid or conjugate base? Let's see. Okay, pH of 4 يعني هون. Okay, يعني أنا وين؟ أنا بعد الهاف equivalence. قلنا بهذا الريجن بيكون البيس أكبر من الأسيد. وبهذا الريجن الأسيد أكبر من بيس. لما نبدأ بيكون أسيد. Okay. So بهذا الريجن this one will be more than أكبر من الأسيد اللي هو HC7H5O3. The students researches benzoic acid similar properties to the salicylic acid. Find the Ka is given. Find pKa. طبعا in order to find pKa is minus log Ka يعني minus log 6.3 times 10 to the minus 5 and then you find it. Okay. طيب هلا next question. Okay, هذا question of a different type لأنه مبلشين من البيس ونازلين لعند الأسيد. We start at 12. This means that this is a base. Okay, and this is an acid. واضحة إنه البيس weak لأنه مبلش بكيرف اوكي بس خلينا نشوف. Now we have a sample of this volume 25 milliliters. الأسيد هو HCl. طبعا HCl is a strong acid. molarity of acid is equal to 1.84 molar. Again I will repeat. لما تكتبوا molarity اكتبوا جنبيها A ولا B to know that this is acid or base. طيب following a graph that shows the pH versus volume according during the titration. If 28.25 milliliters of HCl is on the volume of acid, 28.25 milliliters was required to reach equivalence point. Calculate the concentration of the base. Okay. طب هلا عندنا هون نحن we use the volume of base is 25. طبعا in order to calculate the concentration we will use MAVA is equal to MBVB. طب هلا وين الايكوفالنس بوينت بهذا الجراف؟ الايكوفالنس بوينت is 28.25 milliliters of HCl. 28.25 يعني تقريبا هون الايكوفالنس بوينت. لاحظوا انه هاي لازم تكون الميد بوينت لهاد، فانا رح اعمل ستريتشنج لهاد شوي بعدين رح اوديه هيك. اوكي هاي بقيه الجراف. This is the equivalence point. And at equivalence MAVA is equal to MBVB. طيب هلا المولاريتي of the acid 1.84, volume of acid is 28.25, molarity of base is needed, and the volume of base is 25. So I will say that okay, I will use this to calculate the molarity of the base. I'm sorry I cannot do the calculation because I want to rush. طيب هلا بما انه هذا البيس هو عباره عن weak base, I need to find its Kb. طبعا in order to find the Kb I will look at the half equivalence point. إذا equivalence point at 28 نص ال 28 كم؟ 14. Okay, so if we look at this point على هاي البوينت رح أسميها half equivalence. At half equivalence pH is equal to pKa. كم ال pH؟ ال pH 10. So 10 is equal to pKa. Now I don't want Ka, I want Kb. We know that pKa plus pKb is equal to 14. So pKa is 10. So pKb is equal to 14. يعني Kb is equal to 10 power minus 14. لا 4 sorry. Okay, so always in the graphs you find Ka. If you need Kb, you have to change it to Kb. So this is 10 power minus 4. So the Kb is 10 power minus 4. طب هلا بهذا الريجن هذا كله بفر ريجن. اوكي بهذا الريجن بيكون البيس اكبر من الكونجوجيت اسيد وبهذا الريجن بيكون الكونجوجيت اسيد اكبر من البيس. اوكي طب بدي اسالكم سؤال، اذا CH3NH2 is a weak base what is its conjugate؟ طبعا انتم بتعرفوا انه البيس accepts H, so I will add one H here, so it will be CH3NH3+. اوكي زيدوا عليه H plus بيصير NH3 plus. هذا الكونجوجيت اسيد للويك بيس. اوكي طيب I think we have one more question, two more questions. Oh my god, this is too much. اوكي عندنا هذا الجراف the pH versus volume data. عندنا HNO2 is titrated with KOH. طبعا the molarity of the acid is 0.10. This is the base, so the molarity of the base is equal to 0.10 also. Which of the following species is present in the greatest concentration after 6 milliliters of KOH has been added to the solution؟ خلينا نشوف الفوليوم of KOH 6 milliliters. هل هاي البوينت على equivalence ولا before equivalence ولا after equivalence؟ طبعا equivalence point is at 10. Okay, so this is the equivalence point. يعني half equivalence على 5. بما انه هاي half equivalence اذا هون before بيكون الاسيد اكبر من البيس وهون after بيكون البيس اكبر من الاسيد. Okay, so at 6 the conjugate base is more than the acid. What is the conjugate of HNO2? HNO2, if this is a weak acid, الconjugate بنشيل منه H plus بصير NO2 minus so this is the conjugate base. إذا هذا بيكون أكبر. Okay, another question. إذا شفتوا جراف هيك في بقلبه straight up straight up straight إذا هذا بيكون diprotic acid. Okay, شو يعني diprotic acid؟ diprotic يعني عنده 2 H pluses. Okay. طيب هلا ال H الأسيد هو هاد. It is diprotic acid. It will ionize in 2 steps. بما إنه it will ionize in 2 steps, so it has 2 Kas. It has Ka1 and it has Ka2. How can I find Ka1, Ka2? Ka1 is found at the first half equivalence point. Okay. خلينا نطلع أول شيء على هذا الجراف. I will do it in red. Okay, we will ignore this part. Now equivalence على midpoint high. Okay, this is the first equivalence. The first equivalence point is at 25. نص ل 25 is 12.5 يعني هاي أول half equivalence. Half equivalence. Okay, at this point we say pH is equal to pKa, which is equal to 2.5. يعني Ka is 10 power minus 2.5. I will call it Ka1. اوكي طيب هلا السكند جراف رح ناخذ هاي مع هاي مع هاي. هون رح تلاحظوا ان الجمب very weak لانه السكند Ka has a very small number. اوكي اول جمب حتكون big، ثاني مره حتكون small. اوكي if this is the equivalence point is at 50 الهاف equivalence point. شباب هلا شو رح نعمل؟ رح ناخذ من هون لهون. اوكي من هون من 25 لعند 50. شو البوينت اللي بالنص؟ 37.5. هاي تقريبا الهاف equivalence. اوكي so this is the second half equivalence point. كم الKa؟ شوفوا قديش الKa 10 to the minus 10. إذا pKa equals pH equals 10 يعني Ka is 10 to the minus 10. عشان Ka is a very small number هون راح تكون هاي very short. لو Ka big number هاي راح تكون long. اوكي so عندي بتشوفوا الايكوفالنس نصها بتطلعوا Ka1 الايكوفالنس بوينت الثانيه، بس هلا ما رح نبدا من زيرو يعني ما حدا يقول لي 50 25 هاي الايكوفالنس الهاف ايكوفالنس، لا ثاني مره بناخذ من هون لهون. اوكي only this S shape. فthis the distance from here to here بناخذ النص mid point لها. Okay, now this is the last question. 0.2 molar solution of a weak acid. Can we tell from the graph if what are we titrating versus what? طبعا بما انه بادين من more than 2 أو 2 this is acid. This is base. Now the equivalence point is here. It is تقريبا 9 يعني البيس هو strong والacid هو weak. وبما انه weak acid I can find its Ka. This is the equivalence point. Equivalence point is at 10. نص ال 10 5. إذا هاي الهاف equivalence. عند الهاف equivalence pH is equal to pKa which is equal to 5. يعني Ka is equal to 10 power minus 5. طيب he wants the pKa طبعا تقريبا 5. Okay, so we'll choose 5.3. Now this is the last thing you need to know in the titration. I hope it was beneficial for you.